Hi, how to solve a PDE with the chain rule, part 2. In this part, we'll take a more complicated partial differential equation than in the previous videos. We'll take a partial differential equation with second derivatives of f. So let f be a function of two variables, a C2 function, such that the second derivative of f with respect to the first variable that I call t minus c squared, c is just a real number, a given constant, times the second derivative of f with respect to the second variable, x. So d2f over dx squared equals to 0. And we have to solve this using the change of variables, u equals x plus ct, c is the same constant, and v equals x minus ct. So of course we have to build the dependency table as usual, and then we have to use the same idea we used in the previous video. So we need to calculate d2f over dt squared and d2f over dx squared in terms of df over du and df over dv, and eventually as well d2f over du2 and d2f over dv2, and then replace these expressions in the partial differential equation, hoping to get another partial differential equation in u and v that is easier to solve. So let's start first by calculating df over dt. That's equal to df over du times du over dt plus df over dv times dv over dt. Of course, du over dt that's equal to c, and dv over dt that's equal to minus c, because u is equal to x plus ct and v is equal to x minus ct. Then we have to calculate the second derivative, d2f over dt squared. So that's of course equal to the derivative with respect to t of df over dt. So it's the second derivative, right? So all we have to do now is in the first step is to replace df over dt by its value. So that's c df over du minus c df over dv. Then we need to apply d over dt on each one of them alone, because it's a sum. So it will be c times d over dt, so the derivative with respect to d of the first one, which is df over du, I will color it in green, minus c times d over dt of the second function, which is df over dv. Now I will treat each one of these functions as the function f in the beginning. I mean, we know the formula that gives us the chain rule. So df over dt equals df over du times du over dt plus df over dv times dv over dt. Now this function f in red in the formula, I will replace it the first time by df over du, the second time by df over dv. So this will give me d over du times du over dt, d over dv times dv over dt of, as I said, instead of f I will put df over du. Then another time minus the same formula, but instead of the red f I will put the orange df over dv. It will replace the function f. So I have now this complicated differentiation. Now of course I know that the du over dt is equal to c, the dv over dt is equal to minus c, and that df over d or d over du of df over du, that's d2f over du squared, d over dv of df over du, that's d2f over dv du, and so on. So this will give me c times d2f over du squared minus c d2f over dv du for the green part, then minus c d2f over du dv minus c d2f over dv2 for the orange part. But now we can cancel two terms, the d2f over dv du and the d2f over du dv. Why? Because these two second derivatives are equal thanks to the Schwarz theorem, because f is a C2 function. So that's why we can obtain at the end that the d2f over dt squared is equal to c2 d2f over du2 minus c2 d2f over dv squared. Now a similar work can be done to calculate the second derivative of f with respect to x. So we calculate the df over dx first, then d2f over dx2, and doing basically the same work, it will lead us to the value of d2f over dx2, which is equal to d2f over du2 plus 2 d2f over du dv plus d2f over dv2. Now what we need to do is to replace these two values in the partial differential equation we had in the beginning. So we go and replace in the PDE. We get d2f over dt squared minus c2 d2f over dx squared equals to this whole expression. Now we can do some simplifications by cancelling some terms, which will lead to minus 2c2 d2f over du dv equals to 0. But let me recall you something. We did this in the first exercise. The second derivative of a function with respect to u and v equals 0. This will lead to a function f that is equal to a function in the first variable plus a function in the second variable. So that's how we can conclude that our function f of uv is equal to a function in u plus a function in v. So f of xy finally is equal to g of x plus ct, any function in x plus ct plus any function h in x minus ct. Of course, g and h are two c2 functions.